Hello. In this video, I will go over dosage calculation related to oral medications. Okay, so yeah, we're definitely going to do dosage oral medications, tablets and capsules. Okay, so let's begin. Let's start with example one. So example one says we'll have an order of. So I'm not a nursing or a medical student, so if I pronounce these medication wrong, it's because I really don't know. I don't know how to say it because I'm not a nurse um uh or a doctor. So for example one, we have order of ciprofloxacin hydrochloride of 0.5 G POBID. So if you recall, oh, and then available is ciprofloxacin hydrochloride of 200 milligrams per tablet. So if you recall BID, BID means two times a day. So yeah, so we're going to need that information to probably do because there's a part B, two times a day. Okay, so yeah, no, BID means two times a day. Okay, so what we got to do, um, part A says how many tablets should you administer per dose? So we'll do that doing the three methods, dimensional, ratio, and proportion. So let's start with dimensional. So do we have to convert anything? Uh, let's see, we were given 0.5 grams of PO, and availability is uh one tablet. So our final unit should be in tablets, right? Um, I think we got to convert it to mg first. So because we are given 0.5 grams and somehow we have to, because for one tablet there's 250 milligrams. So we do have to do like a double conversion. So we're going to start with what we were given. So we were given 0.5 grams times fraction. And uh, we can't just go from grams to milligrams. We have to first convert grams to milligrams, right? So we're going to put grams on the bottom because I want to get rid of this grams, and then mg, milligrams, times, and then we were given for one tablet, there was 250 milligrams, okay? So this is just an extra step, right? So we put a one under the grams. What is the relationship between milligrams and grams based on your chart? We know that for 1 gram, there is 1,000 milligrams. Okay, so that's something you should know. And then we were given for one tablet, there was 250 milligrams. Okay, that was also given. And they're asking you how many tablets. So this is how you know you're doing it right because your final unit should be in tablets. If it's not in tablets, you must have done something wrong. So as you can see, the grams disappears, so does the milligrams. So you're still, and your only unit is tablet. And how do we multiply fractions? You multiply across, you don't cross multiply. So you could put when you on the top, it's going to be 0.5 times 1,000 times 1. And then on the bottom, it's 1 times 250. Okay. And when you put that all together on the numerator, it should be 500. And then on the bottom, it is 250. And when you put that in the calculator, 500 over 250 is two tablets. Okay. Uh, exactly, two tablets. Okay. Now let's solve the same problem using ratio and proportion. So when we're doing ratio and proportion, first we got to convert grams to milligrams because we were given for one tablet. For one tablet, there was what was it? Yeah, for one tablet, there was 250 milligrams. So before we set up our ratio and proportion, the first step is we gotta first convert grams to milligrams. Okay, mg stands for milligrams. Okay, so how do we do? That's easy, right? We know we were given 0.5 grams times fraction, and then grams units on the bottom and milligrams on the top. We know that for 1 gram, there's exactly 1,000 milligrams. And when you multiply that out, you're going to get 500 milligrams. Okay, so now we can set up our ratio and proportion. So how do we set it up? We can set it up like this. So yeah, on the top, you could put milligrams on the top and tablets on the bottom, or you could do vice versa. You could put tablets on the top and milligrams. It doesn't really matter as long as this matches with this. So if you do it this way, milligrams should be on the top and tablets should be on the bottom. Okay, let's see. We were given 500 mg. We don't know how many tablets should we distribute, so that would be our unknown. And then we were given, for one tablet, there was 250 milligrams. Okay, you could have also done 250 over 1 here and then 500 over x on the bottom here. It would still work out. Cross multiply, so this is 250x equals to 500. And then solve for x by dividing both sides by 250. And you get 2 tablets. Okay, not too bad, right? Now let's do the formula method. It would be desired over have times vehicle, right? So before we do this formula, you got to make sure you are in the same units. So if you are doing the formula method, make sure desire and halves, so this one and this one's are in the same unit. Okay, so first, so you got to convert 0.5 grams to milligrams. And we have done that in part in the ratio and proportion. That was 500 milligrams. So our desired is 500 milligrams, and then our halves was 250 milligrams. And our vehicle is the tablet for one tablet, right? So we are multiplying fractions, so you technically multiply across. So 500 times 1 is 500. 1 times 250 is 250. And you get 2 tablets. Not too bad, right? Part B says, how many tablets do you administer per day? Okay, that's a good question. We, so our dosage is 2 tablets, but how many tablets do we administer per day? So if you go up, it was originally BID, 2 times a day. So 2 times a day. So what that means is, yeah, so in your notes, if you see BID, it just means 2 times a day. So each dose is 2 tablets. So how much is that in total? So 2 tablets times 2. is equal to 4 tablets. Okay, let's move on to example 2. Okay, so in example 2, it says patient has an order for, I can't say this word correctly. I'll try my best though. Atorvastatin. Atorvastatin. I have no idea what that is because I'm not a nurse or a medical doctor. I'm just a math tutor. Um, so a patient has an order for atorvastatin, 20 milligrams PO once daily. How many tablets do you administer per dose round to the nearest tenth? And is the label of your here's the label. Um, it is a Lipitor and it was given 10 milligrams. So this is kind of also important. So the question says, how many tablets? So our final answer, our final units will have to be in tablets. Do you administer per dose, round to the nearest tenth? So let's start with dimensional analysis. Uh, do we have to convert any extra units? No, because we were given 20 milligrams, right? In in the tablets, for one tablet, it's 10 milligrams. So the units are good. We don't have to do an extra conversion. So we can start out with 20 milligrams times, and we were given for one tablet, you could put milligrams on the bottom, tablets on the top. So we were given that for one tablet, there's going to be 10 milligrams, and then fraction over one, and then the milligrams disappears, and then you may multiply across because it's a fraction. So 20 times 1 is 20, 1 times 10 is 10, and what's 20 times 10 is 2 tablets. The direction said did say round to the nearest tenths, but 2 tablets is perfect. You don't have we don't include trailing zeros, so you don't have to say 2.0 tablets, right? That'd be wrong. Okay. Now let's do the second method, ratio and proportion. This one's not too bad. We do not have to do an extra conversion because everything is in milligrams. So we could just set it up immediately, and we can set it up like this. You could put milligrams on the top, tablets on the bottom, milligrams on the top, tablets on the bottom. Okay. So we know that 20 milligrams X tablets, and then we were also given one tablet is 10 milligrams. And then go ahead and cross multiply. So that's 10x equals to 20 times 1 is 20. Solve for x, so you're going to divide this by 10, and you get 2 tablets. Okay, formula method. So we have desired half times vehicle. Um, the desired and have are in the same unit so that we don't have to do an extra conversion. So our desired was 20 milligrams, and our have was 10 milligrams, and then our vehicle was 1 tablet. Okay, so we're multiplying fraction, multiply across. So this tablet has an invisible 1, and then 20 times 1 is 20, and then 1 times 2 is 10, and you get 2 tablets. Okay, example 3 says, wait, did I do that? Yes. It was just asking how many, yeah, it was just asking how many tablets do you administer per dose. Okay, example three. So example three says patient has an order of for uh levothyroxine of 75, that's 75 mcg, PO once daily. Lev Levothyroxine is available in 25 mcg tablets. How many tablets do you administer per dose? Round to the nearest tens. So for first thing I'm going to check is do we have to do an extra conversion? I don't think so because we were given 75 mcg and our availability was 25 mcg. They're the same units, so we don't have to do an extra unit conversion, extra conversion. So let's start with dimensional analysis. So we were given 75 mcg times fraction, and then we know that for one tablet there was mcg. So we were given for one tablet there was exactly 25 mcg, right? That's our availability. And then as you can see, the mcg cancels, and then our units are going to be 75 times 1, and then on the bottom it's 1 times 25, and then that's 75 over 25, which is equal to 3 tablets. Okay. It says round to the nearest tenth. You don't have to put that trailing zero. 3 tablets is perfect. Okay. Ratio and proportion. How do we set up as a ratio proportion? Do we have to do an extra conversion? No, because we are given mcg and our availability is mcg, so we're fine. So you can put mcg on the top and tablet on the bottom, or vice versa. Tablet on top, MCG on the bottom. It doesn't matter as long as this is the same as this. Okay. So let's see. We were given 25. I mean, we were given 75 mcg. We don't know how many tablets. And then we were given for one tablet, there was 25 mcg. And then cross multiply. So that's going to be 25x equals to 1 times 75. So that's 25x equals to 75. Divide this by 25 to 25, get 30 tablets. Okay, formula method, desired have of a vehicle. Uh, so if you recall, desired and have must be in the same unit. So, and they are, so we don't have to do an extra conversion. So our desired was 75 mcg. Our have is 25 mcg. And then our vehicle was 1 tablet. Okay, multiply that out, you get 3 tablets. Okay, example 4. So patient has an order for, I can't say this word, but I'll try my best. I th Yeah, erythromycin of 0.25 grams POTID. So you hear that TID, that means I believe 3 times a day. Wait. Yes. This is example 4. Yeah, TID. Yes, TID means 3 times a day. So if you see TID, that means 3 times a day. Okay, so a patient has an order of this drug, ithromycin of 0.25 grams PO TID 3 times a day. How many capsules do you administer per dose? Round to the nearest tenths. And here is your label of the drug. Um, you just have to know that we were given for one capsule, there's 250 mg. That's all you really need to know. And then that you also need to know the BID represents 3 times a day. Okay. Uh, the others are not really that important. Okay. Let's start with dimensional analysis. So, do we have to do some extra conversion? Uh, we were given is 0.25 grams. Um, oh, in the label, we were given, yes, we do have to do a conversion because we were given grams, and then we are only, yeah, we were given, the only availability is 250 milligrams. So we do have to convert grams to milligrams. So we have to do an extra conversion. Okay. So let's start with dimensional analysis. So we were given 0.25 grams times fraction. And then you're going to put grams in the bottom because we want to get rid of the grams. And then milligrams, right? We have to go to milligrams because that's our availability. And then milligrams on the bottom here, and then capsule on the top. Okay, so let's fill in the blanks. So based on your notes, what is the relationship between milligrams and grams? Well, we know that for 1 gram, there's 1,000 milligrams. And then look at your label. It said, if you look back at your label, it said for one capsule, there's 250 milligrams. Okay, so for one capsule, there's 250 milligrams. And as you can see, the grams disappear, so does the milligrams, and you are left with capsules. So that's how you know you're right. And go ahead and multiply across. So 0.25 times 1,000 times 1. And then on the bottom, I mean, some people could just do it in their head, but I like to show every step. On the bottom, it's 1 times 1 times 250, right? 1 times 1 times 250. And when you put it all together, the numerator is 250. And then on the bottom is also 250. And that gives you one capsule. It said round to the nearest tenth, but remember we don't include trailing zeros, so one capsule is perfect. Okay, let's start with ratio and proportion. So we do have to do an extra conversion, right? Because we were given grams and availability was in milligrams. So first, what I'm going to do is convert 0.25 grams to milligrams. So how do I do that? 0.25 grams times grams on the bottom and milligrams on the top. So for 1 gram, there's 1,000 milligrams, and you get 0.25 over 1, and that is 250 milligrams. Okay, so we're going to need this. This is not our answer, but we're going to need that, right? Okay, so how are we going to set up? We can set it up like this. Let's see, we could put milligrams on the top and capsule on the bottom, or vice versa, capsule on the top, milligrams on the bottom. That's fine, as long as this is the same with this. So uh, we were given, after doing the conversion, we started with 0.25 grams, and somehow we converted to 250 milligrams, and we don't know how many capsules, that's our unknown. And then our availability was for one capsule, or our prescription for one capsule, it was 250 milligrams. Okay, and then go ahead and cross multiply. So 250 times x is 250x. And then 1 times 250 is 250. Divide this by 250, 250, and you get 1 capsule. Okay, let's do the formula method. So our formula method is desired have times vehicle. Remember our desired and have to be in the same units. So you're going to have to first convert 0.25 grams to 252 milligrams, which we already did was 250 milligrams based on step method 2, right? So our desired is 250 milligrams. Our have was also 250 milligrams. And then our vehicle is 1 capsule. So when you put it all together, you get 1 capsule. Okay. There's a second part of this problem. So part B, 4B. So a patient has an order of PO, P, PO, POTID. TID means 3 times a day for the erythromycin of 0.25 grams. The question says, how many capsules do you administer per day? So for per dose, it was for per dose it was 1 capsule. So per day. So this is where you need to know your wording. TID means 3 times a day. So every dose is 1 capsule. So 1 capsule is 3 times a day, right? So 1 cap because it's TID means 3 times a day. So what's 1 times 3? It's gonna just be 3. So that's gonna be 3 capsules. Okay. Okay. Example 5. Um, Patient has an order of the drug omeprazole. I have no idea what that is available in 20 milligrams delayed release tablets. Uh, how many tablets do you administer per dose round to the nearest tenths? So we were given 20 mg, and I think this, yeah, this one, our availability is for 1 tablet is in 20 milligrams. So we were given 40, uh, so your order was 40 milligrams, and our availability is 20 milligrams per tablet. So the first thing I would consider is, do we have to do an extra conversion? No, because we are given everything is in milligrams, so we're good. So you can start it out as this. For dimensional, it would be 40 milligrams times fraction, milligrams at the bottom, and then tablets on the top. So we know that for 1 tablet, there's 20 milligrams, and then the milligrams disappears, and you're left with tablet, and then multiply across, so 40 times 1, and then 1 times 20. That gives you 2 tablets. Okay, ratio and proportion, same idea. So you can start setting it up. You don't have to do an extra conversion because everything is in milligrams. So you can set it up like this. Let's see, you could put milligrams on the top and tablets on the bottom, or vice versa. But this has to match with this, so milligrams here and tablets here. So we would see, uh we were having we have an order of 40 mg, and we don't know how many tablets, so that's our unknown. And then our availability is for one tablet that was 20 milligrams, right? Cross multiply, so this is going to be 20x equals to 40 times 1. That's 20x equals to 40. Divide this by 20, and you get 2. Formula method, so desired have times vehicle. So our units are the same, so we don't have to do an extra conversion. So our desired was 40 mg, and our have is 20 mg times one tablet. Our vehicle is one tablet. And put it all together. 40 times 1 is 40, 20 times 1 is 20, and that gives you 2 tablets. Okay, example 6. So a patient has an order for the drug cit cita citalopram of 30 mg PO once daily. Cital citalopram is available in 20 mg score tablets. How many tablets do you administer per dose? Round to the nearest tenths. So, so we need First thing I'm going to check is, do we need to do an extra conversion? I don't think so. This was 30 milligrams. Our availability was also in milligrams, so there's no extra conversion. So we can just start doing dimensional analysis. So it would be set up like this. 30 mg times fraction tablet milligrams, and then for one tablet there's 20 milligrams. So 30 times 1 and 1 times 20, and that gives you a 1.5 tablet. So it says round to the nearest tenth, so one, yeah, you don't have to round it higher. So it's 1.5 tablets. Okay, let's do ratio and proportion. How would we do it? We would set it up like this. Okay, fraction, and then milligrams, tablet, milligrams, and then tablet. Okay, so we would get uh we have 30 milligrams. We don't know how many tablets, right? And our availability was for one tablet, there was 20 milligrams. And then going across multiply, so that would be 20x equals to 30 times 1. That's 20x equals 30. Solve for x by dividing both sides by 20. And the zeros cancel, so it's really 3 halves, which is exactly 1.5 tablets. Okay, the formula method, the desired over half times vehicle. The units are all in milligrams. We don't do an extra conversion. So our desired was 30. milligrams. Our our availability was 20 milligrams, and then our vehicle was one tablet. So that's like 1.5 tab that's exactly 1.5 tablets. Okay, example 7. Patient has an order for lisinopril 25 mg PO once daily. Lisinopril is available in 10 mg score tablets. How many tablets do you administer per dose? Round to the nearest tenths. Okay, so let's start with a dimensional analysis. My first question is do we have to do an extra conversion? So our desire was 25 milligrams. Our availability was for one tablet, there's 10 milligrams. So everything is in milligrams, so we're good. So we can start out with 25 mg times fraction, mg on the bottom, tablet on top. So we know that for one tablet, there's 10 milligrams, and then the milligrams disappears, and then multiply across, so 25 times 1, and then on the bottom it's 1 times 10, and that gives you 2.5 tablets. Okay, ratio and proportion. So we're going to set it up like this. Uh, we could put milligrams on the top, tablets on the bottom, milligrams on the top, tablets on the bottom, right? No extra conversion because everything is in milligrams. So we were our desire was 25 milligrams. We don't know how many tablets. Our availability was for one tablet there was exactly 10 milligrams. Cross multiply, so this is going to be 10x equals to 25 times 1. So that's going to be divide this by 10, divide this by 10, and you get 2.5 tablets. Okay, the formula method, the desired halves and our desired halves in the same units. Yes, they're all in milligrams. So our desired was 25 milligrams of PO, and then our availability was 10 milligrams, and then our vehicle is one tablet, right? And then that gives you 2.5 tablets per dose. Okay. Okay, example 8. Uh, Patient has an order for sertraline hydrochloride of 62.5 mg PO once daily. Cert sertraline hydrochloride 25 mg. So our availability is sertraline hydrochloride of 25 mg scored tablets. Um, are available. How many tablets do you administer per dose? Round to the nearest tenths. So the first thing is I check is my availability, my desired and availability. Are they in the same units? Yes, they're both in mg. So there is no extra conversion. So we can start with a dimensional analysis. So you can say 62.5 milligrams times milligrams on the bottom, tablets on the top, So we know that for one tablet, there is 25 milligrams, and then the milligrams disappears, and then our unit is going to be 62.5 times 1, and then on the bottom it's 1 times 25, and you get 2.5 tablets. Okay, let's start with ratio and proportion. So there's no extra conversion because they're both in milligrams, so we can set it up like this. We can say milligrams on the top, tablets on the bottom, milligrams on the top, tablets on the bottom. So we were given 25 milligrams. I mean, our desire was 25. I mean, or you could have said, wait, our desire was 62 point. You can set it up like this. You can also do 25 here. It's the same. It won't be wrong. So our desired was 62 milligrams. We don't know how many tablets. And our availability is for one tablet, there is a 25 milligrams. And then go ahead and cross multiply. So this is going to be 25x equals to 62.5. Divide this by 25, and you get 2.5 tablets. Okay, formula. Desire, have, and then vehicle. Okay, everything is in milligrams, so our desire was 62.5 mg. Our have was 25 mg, and then our vehicle is one tablet. And then you are given with 2.5 tablets. Okay, question 9. I think there's only like 11 examples, so we're almost done. So question 9a, it says, patient has an order for digoxin in 187.5 mcg POQ8H. So what does that Q8H means? I believe it means notes. Uh, it means 3 times a day. So if you see the term Q8H, it means 3 times a day. So patient has an order for dioxide up in 187.5 mcg, PLQ8H. How many tablets do you administer per dose? Round to the nearest tenths. So, and then they give us a label prescription. So you just need to know that in this prescription, um, of, the availability is 0.125 milligrams. Um, that's all you need to know. There is 100 tablets, but that's not really important. So my first concern is, do we have to do an extra conversion? So our availability was 0.125 milligrams. Our desire was in MCG, right? So we do have to do an extra conversion. We got to convert MCG to MG. So before you start your dimensional analysis, you must convert MG. Okay, well, we can do that, right? So we were given 187.5 mcg, and we're going to convert that to milligrams. So we put mcg on the bottom and then mg on the top. So for 1 mg, there's 1,000 mcg. Oh, we could just do it all in one step. We don't have to. Yeah, we could just do this all in one step. And then you could put mg on the bottom because we want to get our final units is in tablets, right? We want to know how many tablets. And you could put tablet on the top. So for one tablet, there is 0.125 mg. Okay. And then put a little invisible one here. As you can see, the mcg disappears, so does the mg. And your final units are in tablets. So just multiply across. So 187.5 times it by 1 times 1. And then on the bottom, it's 1 times 1,000 times 0.125. Okay, put it all together. 187.5 times 1 times 1 is 187.5. And then on the bottom, it's just 1,000 times 0.125. And when you do all the algebra, you should get 1.5 tablets, and it said round to the nearest tenth. So this is perfect. You don't have to go, I got exactly 1.5, so you don't have to do any more rounding. Okay, ratio and proportion. So before you set your ratio and proportion, you gotta first convert 187.5 mcg to mg. Okay, so let's do that real quick. So 187.5 mcg times fraction mcg on the bottom and then mg on the top. And then for 1 mg, there's 1,000 mcg. So that's going to be 187.5. And then this is like an invisible one. So 1 times 1,000 is like 1,000. And you get a 0.1875 mg. Do not round yet. Do not round. So just leave it as it is. So we're going to now set up our ratio and proportion. So we can put mg on the top, tablet on the bottom, mg on the top, tablet on the bottom. So let's see here. Our desire was 0.1875 mg. We don't know how many tablets, and our availability is one tablet based on the prescription. For one tablet, it was 0.125 mg. And you may cross multiply. So this is going to be 0.125x equals to 1 times 0.1875. And you get one, when you solve for x, you get 1.5 tablet. Okay. Okay, formula method. Formula method, desire over have times vehicle. Remember the units for desire and have must be the same. So before you do this, you gotta first convert 187.5 mcg to mg, which we already have, so we don't have to do that step again. We said it was 0.1875 mg. So desire over half times the vehicle. So our desire was 0.1875 mg, and our have is 0.125 mg, and then our vehicle it was one tablet. Put it all together, you get 1.5 tablet per dose. 9b says, how many tablets do you administer per day? So it's the same question from part A. They're asking you how many tablets do you administer per day? So for each dosage, it's 1.5 tablets per dose, right? So do we just how many do we administer per day? So uh if you go back to the problem, it had a frequency of Q8H, Q8H, which means 3 times per day. So each dose is exactly 1.5 tablets, and then it's 3 times per day, so times it by three, you get 4.5 tablets in a day. Okay, let's move on to example 11. So a patient has an order for prednisone 20 PO BID. So I hear that word PID, that sounds familiar. Prednisone is available in 10 milligrams per tablet. So we are given uh, for one tablet 10 mg. How many tablets do you administer per day, round to the nearest tenth? So what does the PID stand for? I believe he said it was so BID means 2 times a day. So if you ever hear the word BID in your prescription, it just means two times a day, twice a day. Okay, we can do that. So blah blah. So the first thing I'm going to ask myself uh is our units the same? We were given 20. Yes, there should have been a 20 mg. This is a typo. 20 milligrams. So yes, we are given 20 milligrams. Our desire is 20 milligrams. Our availability is in milligrams, so everything is good. So we can just start with dimensional analysis. So we are given 20 mg times mg on the bottom, on the top. We know that for one tablet there's 10 milligrams. And then just multiply crosswise. So the milligrams disappear. So 20 times 1. And then on the bottom, it's 1 times 10, which is 2 tablets. Round to the nearest tens. You're fine. You don't have to put trailing zeros. The 2 tablets are perfectly fine. Ratio and proportion. So I'm going to set it up like this. Uh, let's see. You could put milligrams on the top, tablets on the bottom, milligrams on the top, tablets on the bottom. So our desire was 20 milligrams. We don't know how many tablets. And then availability is for one tablet, there's 10 milligrams. Cross multiply, that's 10x equals to 20. Get rid of this 10, and you get 2 tablets. Okay, formula method. So desire have vehicles. So they're all the units are in milligrams, so there's no conversion. So our desire was 20 milligrams. Our availability was 10 milligrams for one tablet. For one tablet. That's our tablet is our vehicle, so that was going to be 2 tablets. Okay. And then there's a part B. So part B says, so each dosage contains 2 tablets, but part B says, how many tablets do you administer per day? Round to the nearest tenth. So it did say BID, which means twice a day. So each dosage is 2 tablets. So 2 tablets times it by 2 gives you 4 tablets. How many tablets do you administer per day? So a total of 4 tablets per day. Okay, last one. Example 11A, patient has an order for cyclobenzap. Patient has an order for, I can't say this word. I'll try my best. Cyclobenzaprine hydrochloride of 10 milligrams POTID. I hear that TID. I think that means, what does that mean? TID means 3 times a day. So patient orders has an order for cyclobenzaprine hydrochloride of 10 mg POTID. How many tablets do you administer per dose? Round to the nearest tenths. And here you got it was given a label. So on the label, you don't really have to worry about this. You just have to know that in this label, there's for 1 tablet, it's 5 mg. That's all you need to know. Uh, and then there's 1,000 available. There's 1,000 tablets. So first step is, do we have to do we have to do an extra conversion? Our desire was in milligrams. Our availability based on the prescription is also in milligrams, so we are good. So we can start with dimensional analysis. So 10 mg times mg on the bottom, tablet on top. For 1 tablet, there's 5 mg, and then a visible 1, and the mg cancels, and then multiply across. So 10 times 1 is 10 times 1, and then on the bottom, it's 1 times 5, and then your unit should be in tablets. So 10 times 1 is 10 over 5, which is 2 tablets. Okay. Uh, let's do ratio and proportion. So we can set it up like this. We can put mg here, tablets on the bottom, mg here, tablets, oops, tablets on the bottom. So let's see here. Our desire was 10 milligrams, but we don't know how many tablets. Our availability was 5 milligrams for 1 tablet. And then if you cross multiply, it says 5x equals to 10. Divide this by 5, you get x equals 2 tablets. And then desire method. So, I mean, formula method is uh, desire over half times vehicle. Our desire was 10 mg. Have is 5 mg for 1 vehicle. I mean, for 1 tablet. And we get 2 tablets. And then the last part for 11 says how many tablets do you administer per day? So we know that 2 tablets is for per dose. So you need to know in the problem it said TID, which you need to know means 3 times a day. So 2 tablets per dose times by 3, you get a total of 6 tablets. That's it. We are going to stop here. So I think the next video will be on Oral medication, liquids, liquids and medication. Okay, we will stop here.